Hello, everyone. My name is Paul Shimabukuro, and I'm a sales engineer with Denodo. So as Paul mentioned, you can use data virtualization to extend your physical data lake into a virtual data lake. So I'm going to talk about that within the context of a data scientist. So typically a data scientist will have to go out and find useful data to answer the question that they're trying to answer. Then usually they have to cleanse that data, format it in a useful format. Then they can do their analysis and algorithm work. And then they'll repeat that workflow as necessary. Now, unfortunately, data scientists spend a lot of their time doing the first two activities on the left and not enough time doing their analysis and algorithm work. So Denodo can help in a few ways. First, we can provide a data catalog where we can search the virtual layer and easily find data. Second, within the virtual layer, it's easy to combine your various data sources together so that you can cleanse and do your formatting right within the tool, and then you don't have to build inside, say, Python or something else like that. And then because we provide standard interfaces like JDBC or ODBC, it's easy for the data scientists to work with their existing tools such as Zeppelin and Python. So here's our scenario for the demo. I'm going to see if I can predict some bike usage based on previous year data. Now I have some bike data that's in CSV format that I just dropped on an S3 bucket. I'm going to get the weather data in JSON format from a cloud source. And I'm going to combine that with date data out of my existing data lake. Now I'm going to combine these three sources together in Denodo. We'll do some transformation and cleansing. And then lastly, I'll consume that in Apache Zeppelin. So let's move over to our demo. So first of all, we're going to start out with our data catalog. Denodo provides a web-based data catalog where it's easy to search and find data within the virtual layer. So here we can search for metadata. So maybe I'm going to search for ride data. As you can see here, I'm brought to a list of search results. Now something like override balances isn't going to be very useful for our bike ride data. And we can refine our search by using categories and/or tags. Now you can define the categories and tags for your organization. Here I've limited down my search results. I can see here that one field matches, and if I click on it, we can see ride shows up in the description. I can click on the view to find out more about it. You see I'm brought to a summary tab where we have a description of our view. We list the field names, field descriptions, and our field types. We can also look at usage statistics, see who's been viewing this, etc. We can see if there's been any relationships defined between this and other views. As you can see here, I've already defined relationships between our date and our weather. We can even view the data right within the tool, so I can query the data, make sure it's what I'm looking for. So maybe I want to see the start date, how many trips were taken. And then because I have relationships defined, I can even bring in data from related tables. So in this case, maybe I'll look at whether the day was a holiday or not. Once I've built my query, I can simply click run and get my results. 2017, 16,000 bike rides were taken, and it was a holiday. Now, from here, I could export the data if I like in various formats. I could even save this query to view it later. To view my saved queries, I can simply click on My Queries. And I can even share this with other users if I like. And I can just copy this and then maybe email it. Now, this was a metadata search where we're searching metadata throughout the system, but we can also search data within the system. Now note that this content search is an index search, so we're not actually hitting the data sources line. So maybe I want to look for a name like Smith, and then I can see where this comes in my data. And I can see here, this is the index data, so Smith is following in the address. I can see all the various fields that we indexed earlier. So here's Smith and the last name as well. So as you can see, the data catalog makes it easy for your users to explore and find the data that they need. Now let's head over to our data virtualization tool. Here's our database administration and development tool. As you can see, this looks and feels like other database tools out there. On the left, we have our Server Explorer, where we've organized our data by virtual databases and folders. And then on the right, we have our open objects. It's really simple to connect to data sources. We can just say new data source and then select the appropriate data source type. Maybe we're going to connect to Salesforce, Excel, delimited files, multi-dimensional cubes. However, most of your data sources will probably be JDBC based. So you can see here, we're just brought to a simple connection dialog where we can give it a name. We pick the appropriate database adapter. So maybe something like we want to do Redshift, and then we just simply fill out information like the host, the port, the database, and then pick our authentication method. Now let's look at something a little different. Let's look at our JSON data source. So you can see here, we just specify where we're getting the data from. In this case, we're going to get it directly from the web. We can specify our HTTP method, the URL, and then if we had to handle pagination, proxy servers, authentication, etc., we simply test our connection. Once we've successfully connected, then we can simply click Create Base View. And what that does is we'll go out, we'll parse the JSON, we'll figure out its structure, and then we'll create a virtual table. Now, I can just run a simple select query against this JSON data source, and then get my results back in a table format. If we look at our execution trace, we can see here that we've actually called the web service. Here's our HTTP call. And again, we've gone out, parsed those results so that it looks like a table. And a similar thing with our S3 data. Here's our connection. We create our base view, fill out the relevant information. You can see here, location, the path within the S3 bucket, my core site XML for authentication, etc. And again, we could simply run a simple select query against this. So even though that these aren't relational sources, we've actually brought in the metadata and made them look like relational objects, so it's easy for everyone to work with these in the virtual layer. So now that we've brought in our various data sources in the virtual layer, we can go ahead and model. So this is easy. We can simply right-click on a table and say join, and then start bringing in the other tables we want to join with. So here's our weather table. Here's our date table. And we can simply drag and drop to create the relations. Now here's our join tabs. We can look at our joins. As you can see, we support normal relational join types like inner, left, and right. If we wanted to add a where condition, we could add it here. If we wanted to group our data, we could group our data here. Here's our output tab where we can do things like shape our data. As you can see here, we have the date field listed twice. So we could either rename it. In this case, I'm just going to remove it. We could do things like order by, say, start time, so that the data is ordered appropriately. Now we can give this a name. We'll call this City Bike. We can save this. Now, if you don't want to develop graphically, we also have our VQual language available. which is roughly a superset of ANSI SQL. And you can see here we just have a simple create view statement, and then here's the select statement that defines our view. So now that we've joined our data together, let's go ahead and start analyzing it in Apache. So you can see here, I'm actually connecting directly to Denodo, and we're going to look at some factors that may influence number of bike rides. So I'm going to look at whether this bike ride happened on a weekend or not. Here makes a little bit of a difference in whether the bike ride happened on a weekend or not. Now maybe I'll look at whether that day was a holiday. And as you can see that here, that's a much more significant factor. But we can go ahead and continue exploring through this, like how much rain happened, what the temperatures were, etc. So we can start building out some factors that may influence the number of bike rides taken. Now notice here, the weekend and holidays are Y and N fields. However, that's not really good for our machine learning algorithms. And so we're going to need to massage the data a little bit more so it can be in a format that's readable for our algorithms. So we can go back to Denodo, and we can do our transformations here. So I've already transformed our data. You can see here, I've just done a simple case statement, so I can take this holiday, and I've converted it from a Y to a 1, and then otherwise we're going to make it a 0. And I've done a similar thing for, say, the days of the week, etc. So now that we've transformed our data, we can go ahead and continue with our analysis. So now I'm going to go ahead and move over to Python. So you can see here we're doing Python. I'm going to go ahead and load some of our data with some select statements here. Now that our data has been successfully loaded, we can go ahead and instantiate a model. And then we can run some predictions here, again in Python. And now that's complete, let's go ahead and we'll plot the results and see how we've done. So as you can see here, here's our predictions in orange and our trips in blue. The model fits okay. Maybe we didn't quite capture our peaks right, but now we can go back and go ahead and view other factors and maybe then update our model and run this again. And also now that this is completed, we could go ahead and even export our data if we'd like, so that you could use it in some other application for analysis. Maybe you want to suck it into Power BI or Tableau, or something like that. So that concludes my demo. Back to you, Paul.